Welcome everybody, Mr. Allen here. I'm going to go through some of the permutation solutions for problem set 1. I'm doing this on the smartboard, so it may not be quite as high quality as some of the other videos, just audio-wise, but I'm going to go through it fairly quickly so that I'm not wasting your time. So first question here, number 4, how many ways can 5 people be seated on a bench? So you can sort of think of all these problems as there are positions available to someone or something, whatever it is we're working with. And then you just have to look at how many different possibilities are there for each position along, in this case, the bench. There are 5 people available, so 5 different people could be in seat number 1. Once that person has been sat, there are going to be 4 people left for position 2, 3 people for position 3, and so on. So it doesn't matter who the person is that goes in the first seat or the end seat, there are still going to be 4 other people left over. And of course, that's the classic 5 factorial. That's also since it is the permutation section, we can sort of say that is a P5-5 question. There are 5 people available. There are 5 people being placed. So you're placing out of the group of 5, all 5 people. So typically that's what these values are. Number available, and this is number to place. And again, with a permutation, the placement is the important part. How many ways can 3 bears and 3 goats sit in a row if the bears and goats must alternate? So once again, I'll start always thinking through these problems with there are these positions available, whether they're positions in a number, positions on a bench, positions just sitting somewhere. A couple of different options here, but the first one, I guess I see there are 6 animals available. So there are 6 different things that could be sitting here. Regardless of which one I choose, whether it is a bear or a goat, there are only going to be 3 in the next position. So if a bear is chosen, there are 3 goats to choose from next. If a goat is chosen for the first position, there are 3 bears left for the next. Now we have a bear and a goat in some order. There are going to be 2 of this guy left over for the next position. Same sort of thing moving forward. 1 of the goats has been sat here, bear here, or vice versa. The third animal has been sat. Now I have to pick 1 of the 2 remaining, again, other animals for that position. And then there's basically 1 left over, 1 left over. So it is either bear, goat, bear, goat, bear, goat, meaning again, if a bear is chosen here, there are only 2 bears left for here, and then there's only 1 bear left for here. Or it could be the alternate goat, bear, goat, bear, goat, bear. But in both cases, whichever of these 6 is chosen first, there are only going to be 3 of the other one left over here. And so 6 times 3, 18, times 2 times 2, looks like 72. And the big thing here to note is even though it's a permutation question, there really isn't a permutation option. I can't do P3, 3 or something. It just doesn't really work out that way. At least not in the global sense here. I suppose you could sort of think of it as there are 3 permutations of bears and 3 permutations of goats. If I start with a bear, then I'll get 36 possibilities that way. If I start with a goat, I get 36 possibilities that way. So there is actually a permutation, a kind of idea there, but it's not global to the whole question. How many arrangements are there if 30 students, 30 desks? Okay, so now I don't want to draw this one out, but again, the idea is there are 30 different possibilities. Sort of think of it from the perspective of the student here. Student 1 walks in, they choose whichever desk they want to. There are now 29 desks available as student 2 walks in, and then 28 desks left for student 3, and so on and so forth. So this is a classic 30 factorial. It's 30 times 29 times 28. Again, thinking about the definition of a permutation, if there are no restrictions of any sort, there's nothing special saying you can't do this or can't do that, these two students can't sit together, then there are 30 students. We need to put them into there's 30 students available. We need to pick which of the 30 will fill desk 1, which of the students will fill desk 2, and so on. The second one here is a little different. The key to recognize is because I have 17 and 25, and of course this is the real world situation often that there are more desks than students, and you would hope in fact that there are more desks than students. We look at things from the perspective of the desk now. I kind of did with the previous one as well, but you can go either way. I think I explained it here as students, but then I thought about here as desks, both of which made sense to some extent there. Here, though, I have to have 25 desks, or I have 25 desks, and I need to place 17 students in those desks. So it's sort of the classic. There are 25 locations, essentially. I need to fill 17 of them, and so that's where we end up. You could also, again, look at it as you're sort of trying to draw it out. There are 25 different students who are available for this specific spot. There are 24, or sorry, I guess I should look at it the other way. There are 25 spots available to the first student. There are 24 spots available to the second student, and so on as we go down here. But you will end up only filling from 25 times 24 times 23, 17 positions across here. So there will be, empty spots at the end. 4 ski toes up the hill, 7 routes down. So this one's sort of a little different, but again, we're looking at how many different possibilities are there, and you just sort of think of it as a run on the ski hill means I go up the hill on one of the toes, I come down on one of the routes. I've got 4 ways to go up the hill times the 7 ways to go down is 28. So again, not really a permutation in the, that we can write as far as hitting the P button on the calculator, but just the logic behind what we're doing here is what we're looking at. Different questions. How many different ways are there? Well, I could go 4 ways up and 7 ways down, 28 altogether. D is essentially the same here. If a room, if the interior decoration, okay, 18, 25, and 7. So basically, there are 18 different choices for the carpets. There are 25 different wall patterns and 7 paint hues. So the question is really how many different room options can I have? And this is what we will end up with. Uh, 20 students are available for 7 scholarships. How many ways can scholarships be awarded? Okay, so a student can only be granted 1 scholarship. So this is, I guess, A in here. Slide this over a bit. This is question A, this is question B. So question A, again, looking at it sort of from the perspective of the scholarships, I suppose. Scholarship number 1, if you will. How many ways can there are 20 different students available to earn scholarship number 1. Once that student has been established, there are going to be 19 left over, and then there are only 18 available for scholarship 3, and so on as we go down the line here. So that is 20 times 19. Whatever that happens to work out to be. And again, it is a sort of a classic question. In this case, I guess you're looking at it from the students. There are 20 students to choose from. You're choosing the 7 who get the scholarships. And of course, the order matters to some extent because scholarship 1 won't be worth the same amount as scholarship 2. You can think of it in decreasing order. Perhaps scholarship 1 is the biggest scholarship, but realistically, that's not necessarily the order that they were given out. It's just that once that first one has been established, that student is not available for scholarship 2. And then the last one here, students can be granted more than one scholarship. I can think of it again in exactly the same way. And I encourage certainly this to be your main train of thought. You can see I've done half of the questions at least by drawing them out. And the other couple, even though they were bigger questions with 30 desks and so on, that's how I was visualizing them. So scholarship 1, there are 20 students available for scholarship 1. The fact that you won scholarship 1 does not mean you can't get scholarship 2, so then there are going to be 20 students available for scholarship 2 as well. And 20, and 20, and 20 all the way across. And so that is your number of different ways students can earn scholarships. There are 20 students available. There are that many different possible combinations. Sorry, I shouldn't use that word. There are that many different possible ways to give those 7 scholarships to those 20 students.